Good morning, students. Today we are going to discuss chapter 9, Mechanical Properties of Solids. So you see the name of the chapter, Mechanical Properties of Solids. Mechanics means what? Something is moving. So here is also we'll consider the movement of the particles that constitute the material. So first of all, let me define the term elasticity. Now, as per the definition, it says that the property of a solid body by virtue of which it regains its original configuration that is shape and size when the external deforming force acting on it is removed is called elasticity. Suppose if you have an object and if you apply deforming force, so what will happen? Its configuration will change. Configuration means shape and size will change. Now when you remove the deforming force, if the object regain its configuration, then it will define as an elastic object, or the property is known as elasticity. Now you see practically if you deform an object and if you remove the deforming force, though it is elastic, it does not regain its configuration 100%. There is always some kind of permanent deformation. So under that case, you are not supposed to say an object is perfectly elastic. So perfectly elastic means what? If it regains its complete configuration when the deforming force is removed. So perfect elastic is very tough. And next one is your plasticity. Plasticity is nothing but the reverse of the elasticity. It means, let me read out the statement. The property of the material body by virtue of which it does not regain its original configuration when the external force acting on it is removed is called plasticity. So you see, plasticity is your what? If you remove the deforming force and if the object does not regain its configuration, then we say the material is your plastic. Okay. So elasticity is your what? Or elastic is your what? If the material regains its configuration when the deforming force is removed. And plasticity is your what? If the material does not regain its configuration when the deforming force is removed, then it is your plastic. So in plastic material, always some deformation is there when you remove the deforming forces. So perfect elastic you are not supposed to get in the nature, or rather you can say all materials are plastic. So it's a very surprising that if you consider a lump of mud and if you give some deforming force on the lump, what will happen? Its shape will change. Now when you remove the deforming force, the mud lump does not regain its configuration, is not it. So as per the definition, the lump of mud is nothing but is a plastic. So that is the science. But in general, if you say the lump of mud is plastic, people will laugh. But as per the definition, it is your plastic. Now we are saying that deforming force, configuration change. So if you want to define this chapter, mechanical properties, you need two parameters. One is your deforming force and another one is your effect of deforming force. Okay, so deforming force is nothing but the external force you are going to apply, and effect of deforming force is nothing but the change in configuration. It means shape, size, etc. So deforming force can be defined by the term stress. Stress is nothing but is your, as per the definition, it is defined as the deforming force per unit area. So stress equal to force by area. So the unit is your SI unit, Newton per meter square. And the dimension is, if you substitute force, then MA, M1, L1, T minus 2. So in down it is L2 area. So 1 L goes off. So M1, L minus 1, T minus 2. The strain is nothing but is your the effect of stress. So the ratio of the change in configuration to the original configuration is defined as strain. Strain equal to change in configuration by original configuration. It does not have any unit because it is of ratio of the two identical similar physical quantity, or two identical physical quantity, you can say. Now the effect of stress is strain, and comparing this stress and strain, we can define another term, that is your modulus of elasticity. So modulus of elasticity is your what? Is the modulus of elasticity is the ratio of the stress to the strain within the elastic limit. Well, when we say elastic limit, it means the system regain its configuration, and up to that much of stress we have to apply on the material so that it regain its configuration completely. There is no permanent deformation when we say elastic limit. So under the elastic limit, the material regain its configuration completely. So modulus of elasticity is your stress by strain. So depending on the nature of the stress and strain, you can classify modulus of elasticity. So here in first case, we are going to define Young's modulus of elasticity. Now in this case, you are going to apply longitudinal stress, and correspondingly we are going to get longitudinal strain. So Young's modulus of elasticity, you see, it is defined as the longitudinal stress to the longitudinal strain. It is denoted by capital Y equal to longitudinal stress by longitudinal strain. Now you see, we have considered a wire, and the wire is suspended by a string. The suspended length of the string we are not considering in our calculation, and the wire seems to be your cylindrical, is not it? So cylinder means it has a specific area of cross section. So in the first figure you see the string is of length capital L. We are not going to consider the length of the string of suspension. Now when we hang a mass of small m, so weight will act vertically downward. So as a result, the string gets elongated and the area of cross section will decrease. So elongated is your L plus delta L. Delta L is the change in length, and this causes due to the suspension of the mass at the free end of the string, whose length is your capital L. Now weight will act vertically downward, W equal to mg. So here we have to define stress and strain if you want to define Young's modulus, because longitudinal stress is there and correspondingly there is a longitudinal strain. So stress equal to force by area. Force is your nothing but the weight, that is your mg, and area is your area of cross section of the cylinder, that is your pi r square if r is your radius. And strain is your change in length by original length. So change in length is your delta L and the original length is your capital L. So if you are interested in defining Young's modulus of elasticity, then you have to substitute this one, y equal to mg by pi r square delta L by L. So mgl pi r square delta L. So this formula is very important for the numerical, and you have to substitute the values to define any of the parameter available if you know the rest of the parameter. So this is first topic, you can say, or the first class of the chapter mechanical properties of solids. More we will discuss in our coming class. So please go through and try to find out your query. Thank you.